Testing alone is not enough. Move from detection to prevention with IBM Ignite Quality and Test, and you can achieve the application quality you need. Ignite optimizes the number and type of tests, automates the testing process, and uses AI to analyze past defects and prevent them in the future. Here's how it works. Here we have an online application that helps complete travel reservations, typical of any commercial reservation system. Testing to make sure this application is working as it should requires a range of test cases. Two complementary approaches can be used with Ignite. Firstly, with Ignite, we can take your existing test cases and run them through our STAM test accelerator. STAM, or Search, Tagging and Modeling, is a feature of Ignite that mines test cases, finds ones that are exactly the same or very similar, and groups them together into what's called clusters. You can then select a cluster and initiate the modeling process. The attributes and values found in these clusters are used in Ignite's test optimization feature, called Combinatorial Test Design, or CTD. The attributes and values in this model represent the behavior of the application from a quality engineer's perspective. The second approach will involve building test models from newly created requirements using the Ignite Requirements Analytics component, potentially within an agile sprint. Ignite will use AI natural language analysis capabilities to analyze each requirement, identifying variables, different values and complexities. These elements will also be fed into the CTD model. You are now constructing business rules which guide how the test plan is put together by combining the values from different attributes. You can also apply restrictions as well. Running a test plan for this particular application, based on the CTD model, we get an optimal set of test cases. With 27 good path and 6 bad path, which represent 100% coverage of business variations. For this application, CTD has done the analysis and found 4 different ways of getting to 100% coverage, including modifying the original set of test cases and eliminating redundant test cases. Originally 43 test scripts were created with 88% coverage by CTD, has identified 26 test scripts to ensure a coverage of 100% of requirements. The generated Cucumber scenarios are then integrated into the Ignite automation framework, called Optimized Test Flow Automation. Then, the Ignite data acquisition feature will search the test data catalog and find the test data which exactly matches the data needed for the automation scenarios and integrate the test data through a database or spreadsheet. We are now going to map, either automatically or manually, the HTML identifiers to find the different objects using XPaths or others, and then store the objects for later use. Now that we have integrated data and objects into the automation test case, we'll start executing the automation. We can run the automation either sequentially or in parallel by different platforms, devices, or browsers, or in parallel by different scenarios. We can run on different environments or browsers, execute the automation, and store the results in this easily accessible report. Here are the results of the test execution. Within Ignite, we can also access an AI Ignite defect prediction feature, which provides insights which predicts the number and type of defects remaining. In this, after 3 weeks of test execution, 198 defects are still predicted to occur within this cycle of tests. This is based on historic patterns previously ingested into the cognitive defect model. Another AI capability within Ignite is called Ignite Defect Classify. It provides real-time insight on the probable defect cause and the most likely component related to the defect. Here you can see the defect details, title and description being entered by the user. This process can be linked to your defect management tool. By using the specific language as reported in the defect, we can compare it to a larger set of ingested defects, which make up our cognitive model, and get advice on the most likely cause of the defect. In this case, the identified cause is code, with a very high confidence level. The instant analysis also provides guidance on the component at fault, in this case the MYTT application. This capability also has a retraining feature for an expert to improve the cognitive model accuracy over time. Overall, quality can be improved with Ignite Defect Analytics, or IDA, a feature of Ignite that uses AI to analyze defects and other artifacts. In this case, defects are ingested into IDA within minutes and, by using the language and characteristics of the defects, reclassified and sorted to reveal defect and quality insights. This analysis allows us to come up with recommended changes to the overall SDLC. To put a high-quality plan together for making changes to prevent those defects. Here's an example of changes based on excessive data-related defects. The defects can be set in the quality plan either manually or automatically using IDA. Here, you can see automatically selected defect prevention recommendations added to a roadmap, which can be tracked on an ongoing basis to resolution. Each part of the Ignite quality platform, optimization, automation, and analytics, works together with AI augmentation to deliver the application quality you need at a time when your applications need it most.